Hello everyone, welcome to my YouTube channel. In this video we are going to discuss the third problem, the C problem of CodeForces Round 690 Division 3. The name of the problem is unique number. The time limit constraint is 2 seconds per test case, and the memory limit is 256 megabytes per test case. The input and outputs are standard. So the problem statement is quite concise. You are given a positive number x. Find the smallest positive number that has the sum of digits equal to x and all the digits are distinct. Okay, fine. We have 50, we can have maximum of 50 test cases and x can also be maximum up to 50. Okay, fine. So output T answers to the test cases. If a positive integer number with the sum of digit equal to x and all digits are different exists, print the smallest such number, otherwise print -1. Okay, fine. Let me erase this. So here we can think that the maximum length of the number can be up to 9 digits number, because we can have since each digit are to be distinct, so the maximum of digits can be 9. Okay, now let's construct a Boolean array. It is of length 9, where 1 2 3 4 5 6 7 8 9. Okay, fine. So here each index will represent whether a particular number contains the digit corresponding to that index. So the index number 0 will contribute to 1, index number 1 will be for 2, similarly 3, 4, 5, 6, 7, 8, 9. Okay, so sorry, I made an extra. Another observation is that since every digit is unique, we can have input which is the sum of the digits. It can be maximum up to 45, because we can see that 1 plus 2 plus 3 plus 4 up to 9, it can be maximum to as 45. Okay, so fine. So at first we'll write the condition that if n is greater than 45, the output will be -1, as no unique number, such unique number exists with the sum of digits greater than 45 and all the digits are distinct. Okay, so here it will be give output as -1. Now let's come to the case where n is less than 45. So this is the Boolean arrays we are talking about, and while coding it down, we take it as a Boolean a Boolean array of size 9. Okay, we'll initialize each cell of the Boolean as 0. Okay, means low, and Boolean can have only two values, high or low. It is at first it's low. Okay. While n is greater than 0. Okay, if n is, here we have initialized k equal to 9. If n is greater than or equal to k, n equal to n minus k. So let me before reading the code, let me first explain it to you. So if you want to minimize a number while maximizing its sum of digits, then it's obvious that we will try to use the large digits. Okay, the main reason is because if we increase the length of the number, the power associated with this number will increase by a factor of 10. So suppose that if you want to construct a number of length 3, which has the sum of digits as 3. Okay, so suppose this is the number. Okay, and this is another number, so it is much larger than 111 is much larger than 3. Okay, let me erase this. The same logic we are using here, that will start by using 9. Okay, so we will initialize k equal to 9. Initially k will be here. After that, if n is greater than or equal to k, means if n is greater than or equal to k, then we will just subtract k from n. Okay, we will put this as 1 because this number is used in, or because this digit is used for making that number, and we will move the pointer to 8. Okay, otherwise, similarly we will iterate for 8 also. Otherwise, if n is not greater than or equal to this very digit, then what we will do, then it is clear that it should be from the left side of the index of the index which we are using presently. So we'll simply what we do, we will use the index of the value of n. Suppose we will want to make a number, suppose with sum 9 and 17 of some 20. Okay, on the minimum number which sum of digits is 20. So what we'll do, we'll start with 9. Okay, so we'll write 9 here. After that we will use 8. Okay, so we have used, now we have only 3 left. Okay, so we cannot use 6 because at that time the sum will get up to 23. We cannot use 5, we cannot use 4, so the only choice we have is 3, so it will be 389. This will be the desired order of the digits, because if it will have a tendency that the minimum number should be associated with the minimum factor power of 10. So suppose it is associated with 10 to the power 0, 10 to the power 1 and 10 to the power 2. So that's what we are doing. So else num n minus 1 equal to true, means here we can say after it was 3 equal to true, n equal to n minus n. After that, okay, so as here we can see n becomes equal to 0, so it will come out of. After that, it will be the final array should be some sort of this one, 0 0. I am getting it for 20. Okay, one. So what we'll do, we'll start from this side, from the leftmost side, and whichever index is 1, we'll just print it out. So finally it will be in the form of an index, and finally we'll give a line of space. So this will be the final solution. The solution is true. As you can see here, my verdict is accepted. I've already done it. So if you enjoyed this video, please like it, share it with your friends, and subscribe to my YouTube channel. Thank you for your attention.